Now, one of the things that's really become more popular, I guess, in recent years is looking at effect size, because effect size looks at the magnitude of the results in the population. So, you go along and what you do is you conduct your study with a sample of the population, right? Sometimes it's a small sample, sometimes it's a large sample, whatever it is that you have to work with. Just because you come up with a significant result in your sample does not necessarily mean that you will see that level of significance if you move to the population. Effect size helps you to look at that and make a determination of, okay, well, if this was this significant in my sample, what magnitude of significance could I expect to see in my general population? And those effect sizes are generally reported in terms of small, medium, and large effect sizes. And we'll look at some values for that next week when we start talking about correlation. I have a handout for you that I'll share. So effect asks, does the treatment work? Significance looks at the precision of that sample-based estimate. Two families of effect size that we want to be sure we understand. The D family, which looks at difference between groups. And so look at, I guess, that mnemonic that can help you remember D and difference. And so differences between or among groups would be used with like your t-tests and ANOVA. So anytime you're looking at a difference between groups or among groups, between groups or among groups, between for 2 groups, among 3 or more groups, right? You're going to use a D value. And we'll talk more about that in 2 weeks when we do t-tests. Next week, we're actually going to talk about the R family of effect sizes, which looks at the strength of a relationship. And when you're doing correlation, that's what you're looking at, is a relationship. So the R effect size is used in that case. Another statistical test where you might use the R family would be regression. There's many others. Logistic regression, for instance, you would look at an R value. And actually, we'll look at some even beyond the simple D and R as we move through the semester. So when you go to report your effect size, make sure that you do 3 things. One, you always want to explain effect size as simply as possible. That's your jargon-free language, right? Number 2, you want to tell what family of effect size it is. Is it D or is it R? Are you looking at an effect size for a difference or an effect size for a relationship? And then you want to provide a confidence interval for that estimate. And we'll talk about confidence intervals for these effect size estimates again as we move along through the semester. We're not going to get into that today. Just know that effect sizes are most appropriately accompanied by a confidence interval. And I'll show you how to do that later in another module, or 3 or 4 or 5. Okay. All right. But that's a good lead in to our next slide, which is confidence intervals. So a confidence interval is simply that interval that is estimated from the sample data. And it looks at the precision of your point estimate. So let's look at this picture over here. You've got your population. You draw a sample out of your population. You see this first line here? Actually, let's look at this line first. We're going from 0 to 100. We've got a straight line down at 50. So 50 is your mean here, okay? All right, on this first sample that you pulled, you actually ended up with a mean that's a little bit less than 50. See that point estimate there? Look at your next sample that you pulled, because what you do is you go back to your population, pull another sample. Here we go. We got another point estimate again, it's a little less than 50, probably in the 45-ish range. Okay, pull another third sample, right? Here it is. This point estimate is larger than 50, maybe in the 56-ish range. I don't know, I can't see it real good from here. But you see what I'm doing. As you go down, each one of these lines represents a sample of people that you've pulled from the population. Now look at the bar. The bar indicates the confidence interval of that point estimate. And so how confident are we that this estimate falls within the range of the true population mean? Okay? That confidence interval shows you that's the minimum and the maximum value for that point estimate. So as you look at all these samples that you drew, all of them except for one falls within the range of an estimate, a point estimate that is an approximation of the true population mean. See this one red one? See how the confidence interval does not cross over that population mean line? That tells you that estimate is outside the range. That particular point estimate is not going to be an approximation of the mean. Now, let's see if we can put this in perspective and understand it a little better. Remember when we talked about setting alpha at 0.05? You just wanted that 5% chance that you've made an error in your assessment of whether it was a statistically significant test or not. In this particular instance, you would have made an error if you said that it was statistically significant. And if you pull a single sample, how do you know? I mean, what's the chances, right? You just kind of, we all take that chance. But you build more confidence in all of your point estimates every time you replicate your study. So replication is one of the things that can help you build confidence that you are getting point estimates that are truly close to the population mean. Okay? So confidence intervals, replication of the study, all of those are good things to help you see, I guess, how much degree of confidence you have in that point estimate. Now, that means too that if you drew 95 samples out of this population, no, let me rephrase that. If you drew 100 samples out of this population, alpha was set at 0.05, right? 95 of them are going to be in the green and 5 of them are going to be red because alpha was 0.05, right? So out of every 100 samples that you pull, you expect that 5 of them are in error and 95 of them are statistically significant. Okay. Again, we'll talk about confidence intervals in more depth as we move through the semester. The final term or idea that we want to cover is the idea of power. And so this is the probability that a test will correctly identify a genuine effect. And you'll often see power represented as 1 minus beta. You also see this described as the 580 convention sometimes, because most of the time we want a power of 0.8 or 80% in our studies. And so you'll do a power analysis to determine, you know, what's the sample size you need to have a power of 0.8. And again, we'll do power analysis as we go on through the semester too. There's some freeware out there that will make it easy for you to do. Some of this you can do in SPSS, but some of it will use some online calculators so that you can see that there's many tools for you to use in calculating power. And there is some freeware that you can download that I find very useful and used for a lot of my research. So, power, 0.8, described often as the 580 convention, meaning alpha is set at 0.05 and power is set at 0.8. So that makes it kind of easy, I guess, to remember that when you're planning a study, go ahead and set your alpha, usually at 0.05, and set your power at 0.8. And remind me if I forget, later in the semester we want to talk about, but what if I can't get to 0.8 in my power? I mean, you have real control over your alpha. You just set it, it's 0.05. But what if the survey you're giving out and the number of participants that you need to be able to get to 0.8 is unattainable? We'll talk about that too as we move along. All right, so this is a short lesson, I guess you would say. I say that and I see the timer's clicking toward 30 minutes here. Quickly, for a review for the test, can you give an example of null hypothesis significance testing? And can you define type 1 error and error rate? You've got the slide back there with those definitions. Can you define type 2 error and type 2 error rate? Again, slide with the definitions. Can you tell me what an effect size is, or a confidence interval, or power? Can you name two families of effect sizes, D and R, right? And can you explain the 580 convention? So this is really, in my mind, a very simple chapter in that we're just learning some definitions and we're really getting ready to apply this moving into the next chapters. The assignment this time is developing some questions based on the information either here in this PowerPoint or in Chapter 2, whichever one that you'd like to use. And it's really just to help you start thinking about these terms. In terms of understanding them, that I think is going to come as we move into the actual data analysis with correlation and t-tests and ANOVA. So if it's not coming immediately, don't stress, it will come. Okay, questions? If you have questions, drop me an email, drop me a text. Either one of those will be fine. And I am going to try to get a Q&A forum up if I get questions. I haven't gotten any questions on Module 1, so I'll kind of wait and see what happens with Module 2, and then I may set up just a general Q&A forum for the semester. All right, everybody, thanks for listening today, and I look forward to seeing you for Module 3. Bye.